for constructor theory, which was and is an idea I had for generalizing the quantum theory of computation.
What if I told you that Google's newest quantum computer might have just proven that we're living in a multiverse? That this mind-bending machine completed calculations in 5 minutes that would take our fastest supercomputers longer than the entire age of the universe, multiplied by trillions upon trillions. Stick around, because what Google's quantum AI revealed about the nature of reality itself will blow your mind. The Willow revolution, Google's quantum breakthrough. Let's start with something absolutely incredible. In December 2024, Google dropped a bombshell that sent shockwaves through the scientific community. They unveiled Willow, a quantum computing chip that's not just fast, it's impossibly fast. We're talking about a 105-qubit processor that makes our most powerful supercomputers look like pocket calculators. But here's where things get wild. Willow didn't just break records, it shattered them into a million pieces. This quantum beast performed a specific calculation called random circuit sampling in just 5 minutes. Now, if you tried to do the same calculation on today's fastest supercomputer, how long do you think it would take? A few hours? Maybe a couple of days? Try 10 septillion years. That's a 1 followed by 25 zeros. To put this in perspective, our entire universe is only about 13.8 billion years old. Willow's calculation would take a classical computer longer than a quadrillion times the age of the universe to complete. That number is so massive it makes your brain hurt just thinking about it. But wait, it gets even more mind-blowing. Google's scientists didn't just build a faster computer, they claim they might have proven something that sounds like pure science fiction. According to Hartmut Neven, the founder of Google Quantum AI, this incredible speed might only be possible if Willow is borrowing computational power from parallel universes. Yeah, you heard that right. Parallel universes. Multiple realities. The multiverse that we've only seen in Marvel movies might actually be real, and Google's quantum computer might be tapping into it right now. The technical breakthrough here isn't just about speed, it's about something called quantum error correction. For almost 30 years, scientists have been struggling with a fundamental problem. Quantum computers get more error-prone as you add more qubits. It's like trying to tune a piano while someone's hitting it with a hammer. But Willow flipped this problem on its head. As Google added more qubits to Willow, the errors actually decreased exponentially. They cracked the code that quantum physicists have been chasing for decades. The multiverse connection. Now let's dive into the really juicy stuff. When Hartmut Neven announced Willow's capabilities, he didn't just talk about processing speeds and error rates. He made a statement that sounds like it came straight out of a sci-fi movie. This mind-boggling number exceeds known timescales in physics and vastly exceeds the age of the universe. It lends credence to the notion that quantum computation occurs in many parallel universes. Wait, what? A Google executive is telling us that their computer might be proof of the multiverse? Let's break this down because it's absolutely fascinating. The idea behind this wild claim comes from something called the many worlds interpretation of quantum mechanics. Picture this. Every time a quantum particle makes a decision, like spinning up or down, the universe splits into multiple realities where every possible outcome happens simultaneously. In one universe, the particle spins up. In another, it spins down. And both realities exist at the same time. Now, here's where Willow comes in. When this quantum computer performs its calculations, it's not just crunching numbers in our reality. According to Neven and some quantum physicists, it might be accessing computational power from countless parallel universes, each one helping with different parts of the calculation simultaneously. Imagine having an infinite army of the world's most powerful computers, all working on your problem at the same time, across infinite realities. That's essentially what Google is suggesting might be happening inside Willow's quantum processors. But hold on. Before we get too carried away, let's remember that this is still hotly debated in the scientific community. While the multiverse interpretation is a legitimate scientific theory proposed by physicist David Deutsch back in 1997, not everyone's buying into Google's claims. Some scientists argue that there are other explanations for Willow's incredible performance that don't require parallel universes. Critics point out that just because something is computationally difficult doesn't mean it requires multiverse-level processing. They argue that quantum computers work through quantum superposition and entanglement, phenomena that are strange enough without needing to invoke infinite parallel realities. But here's what makes this so intriguing. Even the skeptics can't fully explain how Willow achieved such mind-bending performance. Whether it's the multiverse or some other quantum weirdness we don't fully understand yet, something extraordinary is happening inside that chip. Beyond the hype. Let's step back from the multiverse madness for a moment and talk about what Willow's breakthrough actually means for us regular folks. Because beyond all the philosophical implications about parallel universes, this quantum computer represents a genuine leap forward in technology that could change everything. First up, artificial intelligence. Google isn't just building quantum computers for fun. They're planning to integrate this technology with AI systems. Imagine AI that doesn't just learn from massive datasets in our reality, but potentially processes information from countless parallel scenarios. We could see AI assistants that predict outcomes with unprecedented accuracy, solve complex problems in seconds, and make discoveries that would take human scientists decades. The medical field is where things get really exciting. Drug discovery typically takes 10 to 15 years and costs billions of dollars. But with quantum-powered AI, we might simulate molecular interactions across multiple quantum states simultaneously. This could fast-track the development of life-saving medications from decades down to months or even weeks. Climate modeling is another game-changer. Our planet's climate system is incredibly complex, with millions of variables interacting in ways that push classical computers to their limits. Willow-level quantum computers could model these systems with unprecedented detail, helping us better understand climate change and develop more effective solutions. Financial markets could be revolutionized too. Quantum algorithms could analyze market patterns, assess risks, and optimize trading strategies in ways that make today's high-frequency trading look primitive. We're talking about predicting market movements by considering scenarios across multiple quantum states. But here's where things get both exciting and a little scary. Cryptography. Most of our digital security relies on mathematical problems that would take classical computers thousands of years to solve. Quantum computers like Willow could crack these codes in hours or days. This means we'll need entirely new forms of digital security, quantum-resistant encryption that can withstand the power of quantum computation. Google isn't just dreaming about these applications. They're actively working toward them. The company has laid out 6 major milestones for building a large-scale error-corrected quantum computer, and they've already achieved 2 of them with Willow. The remaining 4 involve scaling up the technology and integrating it with real-world applications. The quantum race. Google versus the world. While Google is making headlines with Willow, they're not the only player in the quantum game. This is shaping up to be one of the most important technological races of our time, with massive implications for national security, economic power, and scientific advancement. IBM has been pushing hard with their quantum roadmap, aiming for quantum computers with thousands of qubits by 2030. Their approach focuses on modular quantum systems that can be networked together, creating quantum clouds that companies and researchers can access remotely. Meanwhile, companies like IonQ are taking a different approach with trapped ion quantum computers. which they claim are more stable and accurate than Google's superconducting qubits. Then there's Rigetti Computing, which is working on hybrid classical quantum systems that could be more practical for near-term applications. But it's not just private companies in this race. Nations are pouring billions into quantum research because they understand what's at stake. China has invested over $15 billion in quantum technologies, building massive quantum research facilities and training thousands of quantum scientists. The United States responded with the National Quantum Initiative, allocating billions for quantum research and development. The European Union isn't sitting on the sidelines either. Their quantum flagship program represents one of the largest quantum investments in history, aimed at making Europe a global leader in quantum technologies. Why is everyone so desperate to win this race? Because quantum supremacy isn't just about having the fastest computer. It's about having a fundamental advantage in almost every area of technology and science. The first nation or company to achieve large-scale practical quantum computing will have an enormous edge in everything from national defense to economic development. Google's Willow represents a significant milestone in this race, but it's far from the finish line. Current quantum computers, including Willow, are still primarily research tools. They can perform specific calculations incredibly fast, but they can't yet run the kinds of general-purpose algorithms that would make them useful for everyday applications. The next major challenge is building what scientists call fault-tolerant quantum computers, machines that can run complex algorithms for extended periods without falling apart due to quantum decoherence. Google estimates this might require millions of physical qubits working together, compared to Willow's 105 qubits. The dark side of quantum power. With great power comes great responsibility, and quantum computing brings some serious concerns that we need to talk about. Because while we're getting excited about medical breakthroughs and AI advances, there's a darker side to this quantum revolution that's keeping security experts awake at night. Let's start with the big one: digital privacy. Right now, your online banking, your private messages, your medical records, they're all protected by encryption that would take classical computers longer than the age of the universe to crack. But quantum computers like Willow could potentially break these security systems in hours. This isn't some distant future problem, it's happening now. Security agencies around the world are already working on post-quantum cryptography because they know quantum computers are coming. The race is on to develop new encryption methods that even quantum computers can't crack. But here's the scary part. We don't know how close other quantum computers might be to achieving the same breakthroughs as Willow. If a hostile nation or criminal organization develops powerful quantum computers before we have quantum-resistant security in place, it could be catastrophic for digital privacy and security worldwide. Then there's the question of quantum inequality. Quantum computers are incredibly expensive and technically complex. Only the biggest tech companies and wealthiest nations can afford to develop them. This could create a new kind of digital divide, where quantum-powered AI gives some organizations and countries overwhelming advantages over others. Imagine a world where Google, with its quantum-enhanced AI, can solve problems that no one else can even attempt, where quantum-powered financial algorithms can manipulate markets in ways that ordinary investors can't compete with, where quantum-enhanced military systems make conventional defenses obsolete. There's also the philosophical challenge. If Google is right about Willow tapping into parallel universes, what does that mean for our understanding of reality, consciousness, and free will? If every possible outcome is happening in some universe, do our choices really matter? These aren't just abstract philosophical questions. They could have real psychological and social impacts as quantum technologies become more widespread. Some scientists worry about what they call the quantum winter, a period where quantum hype outpaces quantum reality, leading to disappointed investors and reduced funding for legitimate quantum research. We've seen this pattern before with AI winters in the 1970s and 1990s, where excessive promises led to funding droughts that set back progress for years. Peering into the quantum crystal ball. So where does all this leave us? What can we realistically expect from quantum computing in the next decade, and how might it reshape our world? Based on Google's roadmap and current progress, we're likely to see several major developments in the coming years. First, expect to see quantum computers tackle specific, high-value problems in drug discovery, materials science, and financial modeling. These won't be general-purpose quantum computers, but specialized systems designed for particular applications. The integration of quantum computing with AI is probably where we'll see the most dramatic near-term impacts. Google and other companies are already experimenting with hybrid systems that use quantum processors for specific types of calculations, while classical computers handle everything else. These quantum-enhanced AI systems could revolutionize everything from weather prediction to supply chain optimization. We're also likely to see the emergence of quantum cloud services, where companies can access quantum computing power over the internet without needing to own their own quantum computers. This could democratize access to quantum computing, at least for organizations that can afford cloud services. But perhaps the most intriguing possibility is what scientists call quantum simulation. Instead of trying to build general-purpose quantum computers, we might see specialized quantum simulators designed to model specific types of quantum systems. These could help us understand everything from high-temperature superconductors to the quantum mechanics of photosynthesis. The timeline for practical large-scale quantum computers remains uncertain. Google's own estimates suggest we might see fault-tolerant quantum computers within the next 10 to 15 years, but that's still very much dependent on solving numerous technical challenges. One thing that seems certain is that the quantum revolution will be gradual rather than sudden. We won't wake up one morning to find that quantum computers have replaced all classical computers. Instead, we'll likely see a hybrid world where quantum and classical computers work together, each handling the types of problems they're best suited for. The multiverse implications of quantum computing will probably remain hotly debated for years to come. While Google's claims about Willow borrowing computational power from parallel universes make for great headlines, the scientific community is far from consensus on whether quantum computers actually prove the existence of multiple realities. What's not debatable is that quantum computing represents one of the most significant technological developments in human history. Whether or not it proves we live in a multiverse, it's already expanding our understanding of computation, information, and the fundamental nature of reality itself. Inside, Willow's quantum brain. Now, time to dive deep into what makes Willow tick, because the engineering behind this quantum beast is absolutely mind-blowing. Willow is constructed with a square grid of superconducting transmon physical qubits. But what does that actually mean in simple terms? Think of traditional computer bits like light switches. They're either on or off, 1 or 0. But qubits are like magical dimmer switches that can be on, off, or any combination of both simultaneously. This is called quantum superposition, and it's what gives quantum computers their incredible power. The chip's architecture enables it to handle intricate quantum calculations with greater stability and accuracy than previous iterations. And here's why that's revolutionary. Previous quantum computers were like trying to balance a pencil on its tip, incredibly unstable and prone to errors. But Willow's design is like having a gyroscope that keeps everything perfectly balanced. The superconducting transmon qubits are cooled to temperatures colder than outer space. We're talking about minus 273 degrees Celsius, just a whisper above absolute zero. At these temperatures, the quantum effects become stable enough for computation. The cooling system alone is a marvel of engineering, requiring specialized dilution refrigerators that cost millions of dollars. Improvements over past work were attributed to improved fabrication techniques, participation ratio engineering, and circuit parameter optimization. In layman's terms, Google's engineers perfected the manufacturing process, like master craftsmen perfecting a work of art. Every connection, every component, every quantum pathway has been optimized to near perfection. The square grid layout isn't just aesthetically pleasing, it's strategically brilliant. This arrangement allows qubits to interact with their neighbors in a controlled way, creating the quantum entanglement necessary for complex calculations. It's like having a perfectly choreographed dance where every dancer knows exactly when to move and interact with others. But here's what's really impressive. Willow can perform quantum computations with significant improvements in error correction and stability, using 105 qubits, doubling its predecessor. Doubling the number of qubits isn't just about having twice the power, it's exponentially more powerful. With 105 qubits, Willow can theoretically explore 2 to the power of 105 different quantum states simultaneously. That's more possibilities than there are atoms in the observable universe. The fabrication process itself is a testament to human ingenuity. These qubits are created using the same techniques that make computer chips, but pushed to the absolute limits of precision. We're talking about features smaller than viruses, created in ultra-clean rooms that make surgical theaters look dirty. Quantum computing in the real world. Quantum computing is already moving beyond theory and delivering real-world results across multiple industries. Google's quantum AI team, along with its collaborators, has run experiments exploring quantum gravity, molecular structures, interacting light particles, and exotic phases of matter. These advances are beginning to reshape fields as diverse as medicine, finance, automotive design, and even logistics, proving that quantum breakthroughs are no longer confined to physics labs. One of the most transformative applications is in drug discovery. Protein folding, a notoriously complex problem in biology, plays a crucial role in understanding diseases and developing treatments. Traditional computers can't keep up with the astronomical number of folding possibilities, but quantum computers can simulate many options simultaneously. Major pharmaceutical companies like Roche and Bristol Myers Squibb are partnering with quantum firms to accelerate medicine development, potentially cutting timelines from decades to just a few years, while saving billions in costs. Finance has also emerged as a key beneficiary. Banks such as JP Chase are using quantum algorithms for fraud detection, finding subtle data patterns classical machines miss, while Goldman Sachs leverages quantum simulations to improve the pricing of complex derivatives. Meanwhile, industries like automotive and aerospace are applying quantum computing to optimize battery charging, streamline traffic flow, and design more aerodynamic vehicles. Quantum sensors, which are further along in real-world use, are revolutionizing healthcare with ultra-precise brain scans and early cancer detection, and helping geologists map underground activity with unmatched accuracy. The reach of quantum extends even further into sectors like agriculture and logistics. Companies such as BASF are using quantum simulations to study fertilizer interactions at the molecular level, helping farmers boost yields with fewer chemicals. Logistics giants UPS and FedEx are applying quantum algorithms to delivery systems, saving millions of gallons of fuel each year by analyzing thousands of real-time variables simultaneously. From food production to package delivery, quantum technologies are proving that their impact is practical, measurable, and already shaping the future. The quantum talent war: who's building the future? The race to dominate quantum computing is as much about people as it is about technology. Fresh PhD graduates in the field are already commanding salaries between $300,000 and $500,000. highlighting just how scarce and valuable these experts have become. Leading the charge is Google's Quantum AI team, a collection of Nobel Prize winners, former NASA scientists, and physics pioneers under the leadership of Hartmut Neven, who previously revolutionized computer vision. IBM is not far behind, assembling its own dream team of quantum theorists and researchers at its Yorktown Heights facility, which has become a hub for some of the world's most advanced quantum research. This scramble for talent has exposed a major bottleneck in education. Universities like MIT, Stanford, and Oxford are struggling to expand their quantum computing programs fast enough, often facing years-long waiting lists. Complicating the matter further, there are too few seasoned experts available to teach the next generation of quantum scientists. As a result, new career paths have emerged almost overnight. Quantum software developers, algorithm designers, and error correction specialists, roles that didn't even exist 5 years ago, but are now among the most coveted in tech. Unlike traditional tech industries that lean heavily on young coders, quantum computing prizes experience with many of the most influential researchers in their 50s and 60s, applying decades of theoretical physics to cutting-edge problems. Meanwhile, the global dimension of the talent race is impossible to ignore. China is investing heavily in quantum education and infrastructure, creating research institutes and offering incentives to lure international experts, prompting some observers to call it a modern brain drain. Startups like Rigetti, IonQ, and PsiQuantum are also shaking up the landscape by offering high-risk, high-reward opportunities, including equity stakes that could make early employees wealthy if quantum technology fulfills its promise. To counter the shortage, big players are also launching their own educational initiatives, with IBM's Qiskit textbook and Google's AI courses reaching hundreds of thousands worldwide. At the heart of this battle lies a bigger truth. Mastering quantum computing could unlock breakthroughs in areas from drug discovery to national security, making the competition for talent one of the most consequential races of the 21st century. Google's Willow quantum chip signals the dawn of a new era, offering unimaginable computational power and hinting at mysteries like parallel universes, all while pushing the boundaries of what we know about AI, computing, and reality itself. Do you think Willow proves the multiverse? Or is there another explanation? Share your thoughts and subscribe for more discoveries.